Hello and what is up, chemistry classes, PHS students, PHS community, and anybody who is tuning in from all across the world. Yes, I know you're coming to PHS or Fabianski PHS Science, which is weird. You're coming from all across the world just to see some information about graphing, specifically how to graph this data and draw a trend line on the metal densities lab. So, without further ado, let's get this started. So you should have your graph paper ready to go. On the y-axis, you will have the mass. And remember, your mass was taken in grams. And on the x-axis, you'll have the volume. And that was taken in milliliters through volume displacement. All right, now this is just a little tutorial. This won't be with any actual data. I'll just be making up the data myself, but this will be to help you guys make your graphs. Now, after you've made your graphs, you've gotten your scales correctly done, you can now graph 3 sets of data on one graph, okay? Just make sure you do them in a certain way. Either you're doing them with dots and triangles and squares, or you're doing them in different colors. I'm going to be using different colors. That way it's you can see it a little bit easier on the computer screen. So I'm just going to make up some arbitrary dots on here, or some arbitrary data points, and we'll go from there. So let's say you did 3 unknown metals. In the first metal, you're graphing the mass and the volume, and you may get something, I don't know, that looks like this. Okay, see those 3 dots? 1, 2, 3. Remember, we only took 3 data points. A second metal, let's say you get something a little more like this. And then for the final metal, let's take blue. You get something that maybe, let's make it really defined so that we can see each different one. None of them overlap. In your data, you may have some overlap depending on what you chose. Remember, we had 5 unknown metals. Okay, so we now have our 9 data points graphed. We have a scatter plot. These 3 we'll say are from data set 1, maybe unknown 1, 2, 3, 4, or 5. The green 3 are data set 2, and the last 3, the blue ones, are data set 3. Okay, remember, you're graphing the 3 trials, the small group, the medium group, and the large group. You are not graphing any densities that you've calculated, nor are you graphing any averages. You're just graphing the rough data, okay? No calculations. So the next thing, so I'm sure you guys are all good with this. The next thing that we want to do, I'm going to need my handy dandy ruler here. The next thing that we want to do is draw a trend line. And when we talk about a trend line, we are talking about a line of best fit. Grab a marker here. We're talking about a line of best fit, okay? The trend line is a line of best fit. Okay, I don't know if you guys can see that. I'm kind of squinting to look at the computer screen. And what this is, it's basically an average. You're taking the line, you're drawing a line that lines up and that accumulates all of these 3 data points in the best possible way. It's taking them all into account. It's like if you were throwing dartboards, you're trying to find that perfect spot that factors all of those darts into effect. So let's draw some trend lines. All right, let's start off with the orange ones. Those are the first 3. Now, if we wanted to draw a trend line of these 3 orange ones, would we draw it here? Okay, remember, here's 1 dot, here's 2, here's 3. Would we draw the trend line down there? The answer is no. All right, it's nowhere near the dots. Okay, so let's put it near the dots. Would we draw it right here? I'm going through 1 dot, and I see the other 2. Here's 1 right there. There's 1 right there. Is that a pretty good trend line? Well, it's better than the first one, but it's not the best one. It's not the line of best fit. Would we come down here? Maybe we're going to draw this trend line where we go through this dot. There's a dot right underneath the ruler right there. And we go through this dot. But we leave this one out alone. And no, not yet. We're getting better, but that's not the best trend line. The best trend line, sorry about that. The best trend line is the average. Okay? Think about it. If this dot was gone and you just have these two, we would draw a line that goes through both of them. But we don't have that dot. So what this dot is going to do is it's going to pull this line up a little bit. All right, and we're going to get a trend line that looks something like this. Notice the trend line does not go through any of the points. And that's all right. Trend lines do not have to go through any of your data points. Okay? If they do, they do. That's excellent. But if they do not, that's perfectly all right. Okay, something to keep in mind. All right, let's try the next set of data. Those are the green dots. There's one there, and then there's one right there. So let's try and get this trend line drawn so that it shows a line of best fit, an average of the 3 points. Remember, if it goes through a line, that is wonderful. If it does not, that is okay as well. There is our trend line. All right, so again, it's averaging in between the points. You're drawing a line of best fit. And then we will do our blue line last. Now here, there's a bigger difference in between the points. So that means it's going to be, actually, you know what? Yeah, let's continue with this one. So this one may look a little bit different. Now, the trend lines may all be slightly different. That's okay. Remember, we have 3 sets of data with 3 different slopes. Okay. Your trend lines will definitely look different than mine because you are dealing with actual data. I'm just kind of making up things as we go along here, making up the points. All right, so hopefully this gives you a better idea of how to graph and then how to draw that trend line. The next thing I wanted you to do was calculate the slope. Okay, now if you remember, slope, let's grab a marker. I'm going to erase the trend line over here. Slope, we are talking about a change in y over a change in x. It's your rise over your run. Rise over run. And well, anytime we have a delta, a change in, we're doing the final minus the initial. Instead of final and initial, we're just going to say 0.1 and 0.2. So this is going to be really y2 minus y1 over x2 minus x1. Now you're saying to yourself, where do these x's and y's come from? Well, those are points. Now we have a scatter plot here with a bunch of points. In fact, we have 9 points, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 points. And you're thinking, okay, well, maybe I can use any of these points. And my answer to that is no, you cannot. And I'm so sorry for that. I apologize for that. But it is a very specific set of 2 points that you want to use. Okay, or they have to fall in a very specific area. You need to pick 2 points on each trend line. Okay, 2 points on each trend line. Again, they are not going to be your data points because your data points don't fall on the trend line in this case. So depending on where your trend line is with your graduations on each side, you're going to want to pick 2 points that fall perfectly on graduations on your x and y axis that also fall on your trend line. So, we could just say, hey, here there might be these 2, here they're this, maybe here there's one down there and one way up here. Then what I would suggest you do is I would suggest you write the coordinates, the x, y coordinate for each of these points. Oops, x and y. And this will help you to then say, okay, it's going to be this minus this, this minus this, and it's always final minus initial. So if we look at the blue line, this data set out here, this data point is the final, this is the initial. This is the 2, and this is the 1. So it's y2 minus y1 over, divided by, x2 minus x1. All right. So let's say, for example, the slopes were, I don't know, I'm just making these numbers up. 7 over the x, and the y is 3. And here the x is, oh my goodness, let's say the x here is 3, and the y is 1. So if we were to find the slope, we would take the change in y over the change in x. We would take y2 minus y1 over x2 minus x1. So that would be y2 would be 3 minus 1 over 7 minus 3. So that would be 2 over 4, which would be 1/2. So the slope of this blue line, according to my numbers that I made up, okay, you are going to have defined numbers based on your graduations and based on your data points. The slope for this blue line would be 1/2. All right, you are going to need to find me the trend lines as well as the slopes for all 3 sets of data. Now, looking a little more closely and a little more in depth at this, we have a slope, and that slope is calculated by dividing y's by x's. Take a look at what the units are for the y's and the x's. The unit for y is grams. The unit for x is milliliters. So your units are grams over milliliters, grams per milliliter. That is the unit that happens to be used for density. So guess what? By calculating the slope of your data, you've actually found the density. All right? So I hope this has helped you in graphing and drawing trend lines, calculating slope. Please, guys, take pride in your work. Do an excellent job. If you have any questions, email me or chat through the Teams. Whatever, I will answer your questions. I promise you that. Good luck, and have a wonderful and safe weekend or day whenever you happen to be viewing this. And this is Mr. F saying, take care, enjoy chemistry, because without chemistry, you just have a periodic table with 118 elements, and it just is. So, yeah, everybody have a great day. Mr. F saying, stay safe. I will see you all in class. Bye-bye, guys.